Okay, little review. Question came up about the Bernoulli equation. Here's a form of a Bernoulli equation. And your premise, and it's important to understand your premise and the conclusion you get out of the premise. The dots need to be filled in. We're not going to take the time to do that now. We worked that out rather thoroughly back in January. The premise is that V equals y to the m, and that should convert the equation to a form v prime plus some function of t times v plus some other equals some other function of t. I'll call this function p tilde, call this function q tilde. Now that's not a notation you get in the book, but it's convenient for stating what happens to the equation. Okay, so whether you work out the details or not, you end up using the power of m that accomplishes this is 1 minus n, where n is the power of y up here. And then your p tilde is just going to be related to your p by the constant 1 minus n, q tilde related to q again by the constant 1 minus n. Okay? Where n here is, of course, the value of, well, the exponent of y over on this side. Okay, so we're working out this example. So what are we going to use for n?
3.
I'm sorry?
3. You said for n? 3.
Yeah, I'm sorry. What are we going to use for m?
-2.
Okay. Change variable 2 and that means m is going to be -2. So v equals y to the -2. Now, if you don't want to remember all these constants and all this stuff, it's easy enough to work out your change of variable. Okay? So let's go ahead and work that out. Well, your dv dt is going to be -2y to the -3, but you have a chain rule also because y is a function of t and your derivatives with respect to t. So that would be dy dt, so that your dy dt, now, equals what? Okay, it's going to be -1/2 y cubed dv dt, right? But of course, v is y to the -2, okay, which means that y is v squared, right? No. Sorry, y is 1 over the square root of v. Sorry, 2v squared. You know, I don't know why this always, this whole equation just causes me to make really bonehead algebra errors. So I've got to be very careful when I write things out. I don't know what it is. The exponents get a little tricky when you get in here, but it's just algebra 2. Okay? Apparently losing my ability to do mental arithmetic and algebra 2. Okay, anyhow, you got v equals y to the -2, so that y equals v to the -1/2, which is 1 over the square root of v, right? So that y cubed is reciprocal v to the 3/2. And then it follows that dy dt is negative 1/2. Well, we'll just do it 1 over 2v to the 3/2 dv dt. So now we can begin translating this equation. Well, we don't just begin, we can translate the silly equation, okay? So we get y prime plus p of t y equals y to the n q of t. So negative 1 over 2v to the 3/2 dv dt plus p of t y. Well, p of t is your t squared, right? So that's t squared. Now y is, as we saw, 1 over the square root of v, right? And that equals then y to the n, okay, where n is, sorry, okay, y to the n in terms of v is then going to be, n is 3, power of y here, right? So you're going to have e to the t times y cubed being the cube of 1 over the square root of v, right? So that's going to be 1 over v to the 3/2. Okay?
And now we want to convert it to the v form, right?
Yeah, now we want to get a dv dt out here. Now, if we multiply through by v to the 3/2, all the numbers are hopefully going to come out right. I just kind of looked at it in my head. It looks like they will, but let's write it out carefully because we don't trust my head. Okay? And we're also going to multiply, well, we're going to multiply by negative 2v to the 3/2, right? So we get dv dt plus t squared, well, it's minus 2t squared, times v to the 3/2 over the square root of v, well, that's just v, right? And that equals, well, lo and behold, we get negative 2e to the t. Now, does that match the form that we're supposed to get over here? Okay, well, our p tilde of v is now negative 2t squared, right? Now, they should both have the same coefficient, okay? And this is just some coefficient times your p of t, which is your t squared. Well, that coefficient is negative 2. In other words, p tilde is negative 2 times p of t, right? And q tilde is negative 2 times your e to the t, your q function. So hopefully negative q is equal to 1 minus n. Okay? Well, what's n? Well, we figured out that n is 3, right? And 1 minus 3 is negative 2. So this is and this is without writing out all the details, q of t is just e to the t. Of course, we need to identify these things in reviewing. And this is kind of the overview. Okay? Now, we could have just said, okay, n is 3, so this is going to be negative 2p of t. Okay? And this is going to be negative 2q of t. So we could have written this out directly if we remembered this. But if we don't remember this,
And I probably won't
we can
remember
do
that,
this.
so it's a good thing I asked you.
yeah, I mean, there's a question of just how much you want to remember.
Yeah.
Personally, I don't want to remember any of it except that we're going to make this change a variable and we're going to figure out what value m has to have to put this in the form we want. And then I'm going to screw up the algebra and get it wrong. Okay? But if I'm really careful, I won't. And if I get it wrong when I check it, it's not going to work and I'll go back and fix it, right? Because, you know, I solve a Bernoulli equation a couple times a year in this class. Okay? So I don't solve a lot of them. I don't have to memorize this. I mean, I've got a, well, I'm no longer, but I've always had a pretty good memory. Okay? So if I wanted to memorize this, I could, but why clutter up my brain, okay, with a bunch of stuff I seldom use when I can clutter it up with premises?
Right.
It's less cluttered, right?
Right.
Now, if your algebra isn't reliable enough to do this, and apparently mine isn't because I almost never get it right when I work it out, okay? There's this one little thing with exponents that I just do quickly without thinking about it, and it's all wrong, okay? And it's, like I say, it's just algebra 2. I'm just not careful enough.
Right.
Well, that's because I'm trying to usually work it out in class and don't want to take a lot of time. Okay, if I really needed the solution, I could do this. Okay? Okay, well, the point is, unless I'm using a lot of Bernoulli equations, there's no point in remembering this. And if I work it out once, I'll remember it long enough to do a lot of Bernoulli equations in the near future.
Right.
And that future has to get nearer and nearer as I get older and older. You're young, okay? You figure out how to balance the whole idea of here's the premise and everything follows, okay? Or here's the premise, I don't want to do this stupid algebra, I'll remember this, and then everything follows. Or memorize this, and you don't have to go through this, okay? I don't care, okay? You balance it out. If you're going to be a theoretical mathematician, I definitely recommend just going from the premise and working it out. If you're going to be an engineer, anything that works, okay? Depending on how theoretical you're going to be in your engineering.